And at the morning, we did the same thing with Michael, but it changed roles. At the morning, Michael was online and I was in person. And now we have Michael in person and I'm online. And this time we'll be needing a little bit of toilet paper. Of course, mine is not toilet paper, it's kitchen paper, but it still works. Michael, do people have the things on them? Do they have sheets of paper? All right, nice. So, paper is really interesting material. Can somebody say what is paper made out from? For some reason, I don't hear anything. So I'll just assume that you're saying wood, because paper is made out of wood, like the trees you see right behind me. So paper is done in a really, really easy way. You just take a big chunk of wood, you crush it good, you put a lot of water in it, you crush it more, and it becomes fibrous sludge. And that fibrous sludge goes through two rollers and it's rolled into long sheets of paper. Being rolled means that we expect the fibers to get arranged. So paper ought to be anisotropic, which means that we can check the direction of the fibers. So let's first start with piece of paper, and you see the perforated ends are upwards and downwards, and on the sides we have the smooth edges. So the perforated edges on the top and on the bottom. All right, are you holding your piece of paper like that? All right, nice. So now with pointer and thumb we hold right on the top here, and with the other hand right on top here. And when I count to 3, we just stare. One hand to front, one hand to back. 1, 2, 3. All right. Well, do we have two almost perfectly straight pieces of paper? Wave your papers for yes. All right, nice. Okay, so we assume the fibers go that way, from perforation to perforation. So now let's put that aside, but don't throw it away, just put it aside. And let's take another one. This time we're holding it with the perforations on the sides. So the smooth edges should be on the top and on the bottom. So now, if we're correct, and the fibers are really going that way, and the paper is really anisotropic, we shouldn't be able to do the same exact thing. So we're holding the piece of paper right now, like that. Pointer finger and thumb on one side, pointer and thumb on the other. Are you ready to try to tear? All right, 3, 2, 1, go. Did it work? Check your pieces of paper if it didn't work. Because with me, it certainly did not. As you can see, where I held it, it teared well, and then it just went straight back to the normal proper direction. So now, hold it like before, and right in the middle, try it again, and easy peasy, isn't it? All right, so now we have half of that piece, and we have the other two, right? Can you hold them all together? All 3 pieces together. Can you do that? Michael, wave something in front of the camera if we can do that. All right, cool. So now we are holding the three pieces. So the similar way, the perforations top and bottom. Right in the middle, if it's really as easy to disconnect the fibers, we'll be able to do it again. So we are holding right in that right way, and there. And it should be as easy peasy as before, and we even should be able to do it one more time. So one sheet of paper over the other, so all 6 pieces, and 3, 2, 1, there. And it should be as perfect as before. And why did we do that? Because now we can arrange them in a little pom-pom, which of course, if you have small school children to do that, they're quite excited when we get to the pom-pom part. All right, so next one. So we know that we have fibers in the sheet of paper, and we know that the direction. So let's see how strong is the paper. So we're holding another piece, and you see the perforations are on the sides. And I'm going to fold it 1 time, fold it 2 times, and slightly crunch it. I'm not twisting anything, I'm just crunching so it looks a little bit like rope. Are you doing that? Michael, if we're doing that and it's fine, wave something come from the camera. All right, cool. So let's now see how strong is that. I'm going to hold it strongly with one hand and with the other, and with my middle fingers I'm going to pull here, and on 3 we pull. All right, 1, 2, 3. Well, it breaks quite easily, isn't it? The reason is because, as with the tearing, the fibers are in one direction, but they're not really holding tightly. So let's remedy that then. We're going to take another piece of paper, hold it the same exact way, with the perforated pieces on the perforated sides on left and right. We are once again going to fold it once, and maybe twice if it's a big piece of paper. But then we are going to twist it. We are going to make a twisting motion. We are making a wick. The same way that we can make a wick from fabric if we want a wick for example, spirit burner. And we roll it and twist it until it's hard. So now, are you ready with that part, Michael? All right, nice. So now the same exact way, hold it really strongly, and on 3 we pull as our life depends on it. All right, 1, 2, 3, pull. Is it easy peasy? Wave your pieces of paper if it's not easy. Mine didn't even break. This is because our fibers now are really strongly weaved to each other. They have a lot of friction to each other, and it's quite hard to pull them apart. But we can do a trick. You should have a little bit of water. Is that right? All right, nice. So what we're going to do is we're going to wet the middle of that wick. And I'm going to do it in a a bit more obscure way. So wet the middle of your wicks. Okay, Michael, are we ready? All right, so now we have a wet part in our wick, and now again on 3 we pull. 1, 2, 3. Substantially easier. Well, why is that so? Well, of course, because our fiber work quite close to each other. But now water went in, and you know water is sticky. Michael really likes to say that. So this water goes in the small crevices and spaces between the fibers and make them grow a bit. So they make them swell. And the swell fibers have quite a lot more space between them. And now it's not filled with air and it's not fibers touching each other, it's water. And water is quite slippery. So now we can pull the fibers quite easy apart. And Michael, do you have the oil? All right, I don't though. So I'm going to leave you in the hands of Michael to see the last part with the last piece of paper. Hey, Astrinos. All right, so these were the techniques with a little piece of paper, and I hope you enjoyed it in our little workshop with that. I'm Nasko from somewhere on the road in Bulgaria, and I thank you for your attention, and I hope you like that little workshop. And Michael, we'll see each other next Friday, right?
Yes, on Friday I'll have biked from Terrachin to Sofia to see Nasko at the Sofia Science Festival. So I'm looking forward to seeing you in person in less than a week. Thank you again, Nasko. This has been great.
Thank you. Have fun.